The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is an hour with Big Data and Hadoop architecture. And our guest speaker today is Sudhir Rawat, Support Escalation Engineer. Sudhir has completed Masters in Computer Application and MBA in IT. He has around 10 years of experience in IT industry. He worked on different technologies like Java, .NET, Oracle, SQL Server, and business intelligence. He is working as a support escalation engineer. His areas of focus are Microsoft Business Intelligence Suite and Big Data. He is passionate about the magic, analytic, and mining that can be done on data that can help business to deliver great results. He holds certifications including Microsoft Certified Technology Specialist, Microsoft Certified IT Professional, and Microsoft Certified Trainer in Microsoft SQL Server Business Intelligence. He is active on various forums like TechEd India, Reboot, Social Community, SQL Server Geeks, and various colleges and business units. So, without further delay, I introduce you all to our guest speaker. Over to you, Sudhir.
Thank you. Thank you very much, Aradhana. And once again, welcome all of you on today's presentation. As Aradhana mentioned, my name is Sudhir, and I'm going to speak about the basics of big data and the Hadoop architecture. So, without any further delay, let's go ahead and look into the agenda, what we're going to discuss in today's presentation. All right. So, we'll keep our focus and start from very basics, and some of you already been reading or maybe work on the big data and have some knowledge. So the plan is we'll start with the big data. We'll look into how behind the scenes Hadoop works to solve the big data problems. We'll talk about the key components of Hadoop architecture, which is storage, and in that module, we'll talk about how storage works and how it gets distributed in different nodes in the cluster. And then we'll talk about the MapReduce framework, because once you store your data onto the Hadoop platform, how parallelly is going to get the data back to you. We'll go ahead and look into that via this MapReduce framework module. But before we go ahead and talk about the big data, mainly people think about whenever we talk about big data, they think about we're talking about huge amount of data. But what that storage capacity we are talking about, right? When we say big data, okay? So if you look into your college days or maybe school days, where we used to have data in KBs and MBs, and we used to have the small floppies where we take the data and put it onto the drive and access the data and so on, right? And from from that generation, I would say that era, the data is growing over the period of time, right? And nowadays, if you look into the data into the organization, it's in gigabytes, or maybe in some company with terabytes, and in some social media sites like Facebook and all, you will read that their data, their handling is in petabytes, right? We're also talking about beyond that. We're not only talking about the past or the present. We're also talking about what happens when data grows beyond that. Going forward, if it is crossed to petabytes and reached to exabytes or zettabytes and yottabytes, right? So this particular slide, just to give you a clear picture in your mind that how the data is grow and how much data that we are talking about over here. Some of the data facts that I would like to give all of you. So if you look into the New York Stock Exchange, which basically generates 1 terabytes of trade data per day, right? Which is a huge amount of data that they generate, right? Facebook, which is a social site, hosts approximately 10 billion of photos, right? Which takes up around petabytes of storage, right? Earlier days, we used to have that reel cameras, where we have to put the reels, take these snaps, and then, get it print from the markets, right? During that time, people are tend to use camera very oftenly, when very, I would say, important occasions come across, they take the pictures and, get the print, right? But now, everybody has camera. If you even look into your mobile, we have the camera, and whenever we go, if you like something, we take a pic, and from the mobile, we go ahead and upload that photo onto the social media site to share with your friends and the family, right? So the storage is, getting more. And if you look into this Ancestry.com site, which basically have around 2.5 petabytes of data that they handles, right? Twitter, very popular site, which handles, around 8 terabytes of data per day, right? So these are some of the facts, which is happening in the industry or in the market, you can say. Give you some more perspective about the applications and what kind of a data that they are generating, right? If you look into the ERP and the CRM and the transactional web application, which are the classic examples of system processing transaction, they are very highly structured data, and these systems is typically stored in transactional database, maybe SQL or maybe some other databases. Web 2.0 are about how people and things are interact with each other or with their businesses. Weblogs, user click streams, social interaction and feeds, and user-generated content are the classic place to find interactions data. Okay. Ambient data trends is coming Internet of Things. Mary Mecker has predicted that around 10 billion of connected devices by 2015. Sensors for heat, sensor for motions, pressure, RFID, and GPS chips, which such things are mobile devices, area machines, and even aircraft engine, provide just some example of things that output ambient signals, right? So there are multiple types of data, personal, organizational, public data, private data, right? So we should not minimize our thinking to just data that flows through an organization. For example, the mortgage-related data that you may have cloud benefit from being blended with external data found in Zillow, for example. Okay. Moreover, the government has an open data initiative, which means that more and more data is being made publicly available. Okay. So to most, the big data is about the size of the data and its terabytes or petabytes of data. However, this is not the only thing we should be looking at, right? So the volume of the data is one aspect. However, it's commonly summarized as the 3 V's of data as follows. Actually, I would say it's a 4 V. Let me just explain what these 3 V's are all about, and then probably I'll tell you the 4th V as well, which I feel should be there when you actually going to implement such kind of a infrastructure or any solution based on such platform. So the first one is the volume, typically thought in the range of the petabytes and exabytes. However, this not be necessarily the case. It could be gigabytes or even terabytes of data, which happens to be semi or multi-structure. Okay. So the Hadoop big data solution is response to two divergent trends. On the one hand, because the capacity of hard drives has continued to increase dramatically over the last 20 years, and the vast amounts of new data generated by websites and by new devices and instruments generation connected to the internet can be stored, right? Variety, which is any types of data. So most generated data is messy, right? So diverse data sources do not provide a static structure, enabling the traditional RDBMS timely managed, right? Social networking data, for example, is typically text-based, taking a wide variety of forms that may not remain fixed over time. Data from images and sensor feeds present similar challenges, right? Velocity, velocity means speed at which the data is collected. So the rate at which the data is becoming available to organization has followed a trend very similar to the previously described escalating the volume of data, and is being driven by increased e-commerce clickstream consumer behavior, logging, and by the data associated social networking such as Facebook and Twitter, Okay. We also have, the smartphone and the tablet device, which basically generates data and posts it onto the online, right? So these are the three V's of the big data. Now the fourth V that I was talking about earlier is the value, right? So value means, what is the ROI uh, of a project that I'm going to implement with such problem, right? So that also you need to look into that, right? So return of investment, that's another area which I feel it should be there before implementing or making an investment on such platform. Do you really need that platform or not, right? Now, if you look into the market trends, there are new set of questions which comes up in the today's generation. So, for example, questions on social and web analytics. That is, what is my brand and product sentiments, right? How effective is my online campaign was, right? How I'm reaching to the customers, right? How can I optimize or target the correct audience, right? So these are the questions, generally get asked to drive the business, right? Questions that require connecting to the live data feeds. Example, the large shipping company uses the live weather feeds and traffic patterns to fine-tune its ship and truck routes, leading to improved delivery times and cost savings, right? Now, questions that require advanced analytics, which is financial firms using machine learning to build, I would say, better fraud detection algorithms that go basically beyond the simple business rules, involving the charge frequency and location to also include an individual customized buying pattern, ultimately which is leading to a better customer experience. Okay. Organizations that are able to take advantage of big data to ask and answer these new types of questions will be able to more effectively differentiate and derive the new value for the business, whether it's in the form of revenue growth, cost saving, or creating the entirely new business models. Okay. I was reading Gartner's report some time back, and one of the statements that clicked me is that by 2015, the business that built a modern information management system will outperform their peers financially by 20%, right? And McKinsey agrees, confirming that organizations that use data and business analytics to drive decision making are more productive and deliver higher returns on equity than those who do not, right? Okay. Just wanted to share some of the industries where this particular platform is using, or maybe people are taking advantage of the platform. So these are the various that I put around to the images, like IT infrastructure optimization, legal discovery, social network analysis, traffic flow optimization, and so on. Okay. Let me move on to the next slide. Okay. Now, I hope everybody have now understanding of what is big data, and it's not only about the volume that we're talking about. We're talking about the variety and the velocity of the data as well, right? Now, that's the problem that we have. Now, what is Hadoop? So Hadoop is basically a platform, which basically helps you to solve these problems which we discussed earlier. Okay. Now, what does it contains? It basically contains processing platform for big data processing. That means if you have a huge amount of data, how to store the data, and then how you can use the MapReduce processing paradigm, right? We'll talk about more in details going forward, okay? But this is just to give you a quick overview on it. Some of the characteristics are, it's basically highly scalable. That means you can add more power to your cluster as you need, right? It's a completely hardware base. That means, if in your company you have some servers which is just lying down, you can actually go ahead and use those servers as well. Okay, it's an open source. I'll just go ahead and show you the history of the Hadoop as well, so that will give you a clear picture. But at the end, it's an open source. Apache is heading to that, and if you want, you can actually go ahead and look into the source code of it as well. And if you want to contribute to it, you can actually go ahead and join there, and you can actually contribute to that as well. Okay, so being said, it's an open source. It's very low cost for acquisition and storage cost. Okay. Okay. So as I mentioned earlier, Hadoop is basically well divided in two parts. One is its SDFS, what we call Hadoop Distributed File System, and we'll talk about more in details how it basically works behind the scenes. And then the second part is the MapReduce framework. So once we have the data available on the SDFS, how actually, what the algorithms or what are the framework that is available to read the data out from the distributed system. But before we get into that, let me just go ahead and give you a quick introduction about, from where it comes, the history of the Hadoop. Okay. So Hadoop is basically, was created by the Doug Curtin, the creator of Apache Linux. That's the widely used text search library. Okay. Hadoop has its origins in Apache Notch, and which is an open source web search engine itself, a part of the Linux project. Okay. So Notch was, started in 2002, and it was working as a crawler and search system, which is quickly emerged. So when the Mike and Doug was working on a system where they were supporting a 1 billion page index, which actually costs you around $500 million in hardware, right? They realized that their architecture would not scale to billion of pages on the web. Okay. Now, at the same time, they got some help with the publication of the paper in 2003 that describes the architecture of GFS, which is the Google Distributed File System. Okay. And then which would solve their storage needs for the very large file which is generated as a part of the web crawl and indexing process. Okay. Now, in that particular, the GFS would free up time being spent on the administrative task, such as managing the storage node. Okay. Now, in 2004, they set about writing an open source implementation, the NDFS, which is Notch Distributed File System. Now, in 2004, Google actually published a paper that introduced the MapReduce to the world. And in early 2005, the Notch developers basically had a working MapReduce implementation in Notch. And by the middle of that year, the major Notch algorithm had been ported to run using the MapReduce and NDFS. Okay. So NDFS and the MapReduce implementation in Notch were applicable beyond the realm of the search. And in February 2006, they moved out to Notch to form an independent sub-project of Linux, which is called Hadoop. And at around same time, the Doug Curtin joined Yahoo, which provided a dedicated team and the resources to turn Hadoop into a system that ran at the web scale. Okay. Now, that was demonstrated in February 2008 when Yahoo announced that its production search index was being generated by around 10,000 core Hadoop cluster. Okay. And in January 2008, Hadoop was made its own top-level project at Apache, confirming its success and its diverse, active community. And by the time, Hadoop was being used by many of other companies besides Yahoo, such as Facebook and the New York Times. Okay. And some of the facts after that, the Yahoo on April 2009 won the 1-minute sort by sorting 500 gigabytes in 59 seconds. That is on 1,400 nodes, and around 100 terabytes sort in 173 minutes, which they done on 3,400 nodes. Okay. So that's about the history about the Hadoop. Now look into the first aspect of the Hadoop, which is SDFS, right? Now, what you can see in my screen, we have secondary name node, and the data nodes. Okay, so let's think about this. Whenever you have some data which you want to push onto the Hadoop system, there would be someone who's gonna listen to your request, right? So that request basically come to the name node. Okay, so name node, you can basically say it's the brain of the system, or you can say it's a parent machine, which basically going to hold all the requests and then manage all the data nodes that are there. Okay. So the name node basically takes the request and then it basically distributes it into a different blocks. Okay. For example, if you have, let's say, 1 gigabytes of data, okay, which is around 1024 MB, okay, and let's say each block size, because name node is going to, cut down your data into the various blocks or packets, you can say, okay. So let's say each block size or the packet size is defined as a 64 MB. So 1024 MB divided by 64 MB, somewhere, let me just quickly do a calculation. 1024 divided by your 64 MB, which comes 16 blocks, right? So all these 16 blocks, will get written onto your data nodes, on the different data nodes, okay? Now, your name node basically knows how many data nodes are there in that cluster, okay? And it also knows how many times you want to replicate your data, okay? By default, it's 3, and the reason is if you want to have replication of 1, let's say all your 16 nodes get placed on the different data nodes, and one of the data nodes goes down, you're not able to access your data, right? So your user has to wait, right? So so 1, that's why the reason the 1 is not there default. 2, if you're going to put it 2, and let's say if you have rack implementation and one of your rack goes down, right? Then again your data is not available, right? So we start with 3. That means each block is gonna return 3 times in your cluster on the different data nodes, okay? And that's what you can see on my slides. In the data node 1, we have BL1, that is block 1. If you look into the data node 2, we also have block 1, and in data node 3, we also have a block 1 as well, right? So similarly, each block will be get returned 3 times into your cluster, okay? Now, any point of time, if one of your data nodes goes down, for example, your data node 1 goes down, your name node knows, data is already replicated, so it basically go there and, fulfill your request, right? And any point of time, if you add a new node or a new machine to your cluster, once you configure it, restart your service, the name node will automatically make an entry of it and then, start distributing the data over there as well. Okay. There's also a heartbeat which is keep happening between the data node and the name node as well. Okay, just to make sure that the data nodes are alive. So each time data nodes, keep sending heartbeat to the name node just to tell the name node that I'm alive, I'm alive, I'm alive, right? And you can send the data to me. Okay. So this is your, and each nodes are a different computer. So when I say node, I'm saying it's individual computers, right? So these are the different computers that we have, okay? Now, on the left-hand side, you can see you have the secondary name node, okay? Now, what happens is, your secondary name node will take a replica of the name node, right? So whatever metadata that name node have, it basically gonna take a copy of it into the secondary name node, so that any point of time, if your name node goes down, you can bring your secondary name node and make it as a primary name node. Okay, there is no automatic failover, so you have to bring it your secondary name node in place of the primary name node if it goes down. Okay. All right. So this is about the SDFS storage, how the storage works, and during the demo, I'll probably go ahead and show you, where you can actually go ahead and configure the replication, the block size and all, okay? So all these are configurable. But one thing that you need to keep in mind, with respect to the replication, by default we have set 3, right? You can increase it to 4, 5, whatever number that you feel is good for your business, okay? However, at the same time, you need to keep in mind that you're increasing your storage, okay? Now let's say I have 1 gigabytes of data and my replication value is 3. Okay, so that means that 1 gigabyte of data is going to be written 3 times. So that means I need to have a storage of 3 gigabytes available, right? So if you're going to increase it to 4, 5, then probably you need to have that space as well, 4 gigabytes or maybe 5 gigabytes. Okay, so you can go ahead and configure it, but that's another thing that you need to keep in mind about the storage. Okay, so that's the one aspect of the Hadoop architecture, which is the storage. Okay, the other thing is, maybe somewhere you will read people say name node, data node. Somewhere they will say master node, slave nodes. Somewhere they will, parent node, child node. Right? All these are same, but the way they represent is different. Right? But at the end of the day, we're just talking about the name node and the data node itself. All right. So with that, let's move on to the next part. All right. So that we already talked about. So the another aspects of it, the MapReduce. Okay. Now, because you have your data available in a different nodes, right? So let's say you have 40 node cluster. Okay. So if you have a 40 node cluster, your data is distributed across the 40 computers, right? So how quickly you can actually get the data out of these machines? That's where the MapReduce framework comes into the picture. Okay, so the first part we already talked about. You actually have to push your data onto these different servers, and your files will get replicated. Okay, and then the second step is once the data is there, you can actually go ahead and push your code to the Hadoop cluster, and it's basically going to run that onto the different nodes. So what happens is, when a code that you have written, you send it to the Hadoop cluster in the name node, right? So that code, it gets distributed onto the data nodes, right? Now at that particular data nodes become as a compute node, because wherever your data resides, your MapReduce task is going to run. And I'll show you in a workflow as well, okay? So your data is going to run over there. So your code is get distributed across the servers. And okay. And then the final output will come back to the end user, right? So that they can actually go ahead and view the results. Okay. Now, when we say MapReduce in Hadoop, it's not only the map and reduce which is happening, right? It's not a one function which is happening into the Hadoop architecture here, right? There are different tasks which get performed to get the output, right? So here I've listed what are the tasks that gets involved. So first, it's look into the record reader, maps the records, then combine the data, partition it, shuffle it, and sort it, and then do the reduce. That means any aggregation that you're going to provide, it's basically going to do, and then give you the output format, right? In many cases, it might so happen that you don't have to do any aggregate. I mean, you don't want any aggregates to be happen, right? So there, in that scenario, you can run only the map jobs, right? Let's have a look into the example, which will give you a clear picture how the MapReduce works. And here is the example that I'm going to take. Okay. So on the left-hand side, I have my blocks of the sales file in the SDFS, which basically has the zip code, the customer ID, and the amount. Okay, and the scenario is I want to get a sum of sales grouped by the zip code. Okay, so let's see how basically it works. Okay, so the mapper is basically going to map all the data. So in the data node 3, there are two map jobs which basically runs and extract out the data. Okay, and then it basically put it in a container or in an output bucket, you can say. Okay, then it will look into the another data node 2, and similarly it will put it onto that container, and similarly it will take the data from the data node 1 and put it over into the container. Now this data is now basically going to get to the reduce phase. Okay, so the map phase, we basically did the mapping of the data which was available. Now what we're going to do is we basically going to do the reduce job, right? And why do we want to do the reduce task over here? Because we need the sum of sales, right? We want to do some aggregation on the data, right? So now we're going to reduce the data and see how it's going to work. Okay. So it's basically first shuffles the data. Okay. Now I can say the zip code 53705 and the amount is there in the one, right? And similarly in the other containers. Then it basically going to sort the data, right? Now once it's done with the sorting, it will basically come into the in a particular sequence by the zip code. Okay. And then it basically gonna sum the data based on the zip code, and once it's get done, it basically return out the output. Okay, so this is how the MapReduce is basically works in the Hadoop architecture. Let me move on to the next slide. Now the next step is to understand how this MapReduce program works in the cluster. So here I have an example in the flow. So as you can see, we have a MapReduce program that you have run. So I have run this job. It basically goes to the name node. Okay. Now name node basically initiate the job tracker, okay, which basically basically creates a new job ID. That's the first thing that's going to do, so that later point of time, if you have to troubleshoot anything, you can actually take that job ID and you can actually see in the logs why that particular job ID is failing. Okay, so this is just to uniquely identify the request that the name node is taking. Okay, so job tracker node is nothing but you can consider as a name node. But because we are now talking about the MapReduce framework, so we're talking about the job tracker node, but it's the same machine. Okay, so now you get the job ID. Okay, now once you get the job ID, the third thing is which is it basically gonna copy the job resources. So any customization that you're gonna do on your Hadoop cluster, for example, any particular functionality is not there. For example, if you're working in the BIG, and if you find that a particular functionality is not available in the BIG, and you write your own jar file, then probably that jar file is basically going to get copied onto the shared file system that is on the HDFS itself. Okay, so that when the job is going to run, they basically going to take that resource and apply onto the data. Okay. Now once that's done, the next step is the fourth step. It basically going to submit the job. Okay. Now what's going to happen is the task tracker node, right? These are my data nodes or my compute nodes where my individual task is going to run. So the job tracker basically it's going to create multiple tasks for me, all right? And each task is going to distribute it to the different compute nodes. Okay. In each compute node, we have something called task tracker. Okay, which basically launches and basically runs this map task or reduce task or maybe map reduce task over there. Okay, and once everything gets done, it basically gonna return the results back to the job tracker, and it's again returns that result back to the client. Okay. Now at the 7th point, you can see it basically doing the heartbeat. So it might so happen that if any job is running or any task is running on a particular compute node, right? It might fail. Maybe maybe a software failure or maybe a hardware failure happened, right? So the immediately the job tracker will get to know that the machines are down, and it will basically first try to do a ping 2 or 3 times to make sure whether it actually dies or not. And if it doesn't get any reply from that machine, then probably it will take that particular task and shift it to other data nodes where the data resides, because we have 3 copies of data, right? So we can run that particular task in some other node. Okay. All right. I hope that will give you a clear picture of the MapReduce lifecycle. This is all what happens when you submit a MapReduce. And let me move on to the next step. Okay, and let me just quickly tell you about the Hadoop ecosystem, right? Now, Hadoop is basically written on the Java, all right? So it's just all Java-based programming that has been happened behind the scenes, okay? Storing the data onto the different computers, or maybe, MapReduce framework, all written in Java itself, okay? Now, what happens, there are programmers who are not comfortable with Java, right? There are people who are, they're familiar with other programming language, Python or .NET and so on, right? So how they gonna, understand the Hadoop ecosystem or work on the Hadoop, right? Because if it is Java written, they have to have the understanding of the Java, right, before they go ahead and execute their MapReduce task, right? So what happens in the Hadoop ecosystem, there's an open source community which basically feel that challenge, and what they did is basically they come up with the various projects into the open source community. Okay, and these are the projects that are there, right? So for example, if you are very comfortable with writing scripts, okay, you can actually go ahead and start with the BIG, which is the service which is available in the Hadoop. So what BIG does is, you can write a simple scripts based on the functions which is provided by the BIG, and then behind the scenes, basically BIG generate the MapReduce job for you. All right, so you don't have to, learn Java as such to start with it. Okay, maybe you're comfortable with the T-SQL or SQL-like programming languages, right? So probably then you can use Hive, right? So it basically provides you an interface where you can actually go ahead and type your SQL-like statements, and behind the scenes then Hive basically produce a MapReduce task for you and give the results back to you. Okay. Similarly, we have the Scoop. If you want to import and export the data, we have the Mahout. If you want to do some machine learning on the Hadoop, we have Zookeeper, to monitoring the resources. We have Flume, Uzi. Uzi is there for scheduling the jobs. If you want to maybe pick job or a Hive job, you can actually go ahead and schedule it. For example, if you want to run any pig or any Hive job on every Saturday, you can actually go ahead and use Uzi and go ahead and make it work, right? We also have Apache Ambari, which basically gives you very statistics information about your cluster. Okay. Now with that, let me just go ahead and share my desktop, and let's go ahead and have a look what happens when you get install the Hadoop on your box. Okay, so I'll say end of the slides, and then okay. So now what you can see on my screen, I have installed one node cluster. Okay, that means the name node, the data nodes, all sits in the one system itself. Okay. So once you install it, you basically get 3 icons on your desktop: Hadoop command line, Hadoop MapReduce status, and Hadoop name node status, right? So let me just go ahead and open the name node status, right? We talk about, when we're talking about SDFS or MapReduce framework, we talk about this name node, right? So it basically gives you the information about your name node. So how many live nodes, because it's a one node cluster, I have live nodes as a 1, right? If you want to get into that, you can go ahead and do that. If there are any dead nodes detected by the name node, it will be get under dead nodes. You can go ahead and have a look. All the capacity and all the stuff, you can go ahead and look it from here. Okay. Now, we also have the MapReduce status. So if I run the MapReduce, there you can see it basically a job tracker, which basically tells you how many nodes are there, how many map tasks, how many reduced tasks are running, right? And it will give you all the information, right? So if you want, you can actually go ahead and look into the running jobs or completed jobs, right? So if any job which is running, it will be get listed over here. So if you think any particular job is taking a long time, you can get into this portal and you can get into more detail, for example, if I over here in the completed jobs, it gives me a job ID. Remember, we talk about any program that you submit to the Hadoop cluster, it generates a job ID for you, right? So we get this job ID, and once you get this job ID, if you want to look into the further details, you can click on that. It basically tells you how many map tasks has been initiated, how many reduced tasks has been initiated, right? How many are running, how many are pending, how many completed, how many have been killed. All this information, you will get it over here. Okay. And if you want to further look into that particular map task, you can click on that, and it will give you that task, right? What is the start time, what is the finish time. And if you want to look that particular task, it will give you further information. Okay. Now this is, helpful in a situation where you get stuck, or maybe you want to troubleshoot something, or want to look into the information what's happening into your Hadoop cluster. Okay. Now let me just go ahead and close it out and open the Hadoop command line. This is the first screen that you're gonna get into, and once it gets open, I'll go ahead and start writing my commands. All right. So there are SDFS or the Hadoop specific commands which you need to run. Okay. Now before that, apart from these three screens, when you install the Hadoop, and if you go into the location where you actually install it, you will basically see what all services are there and what are the version of these services which get installed on your box. Okay. So that, for example, you can see we have Hadoop 1.1, Fetch Catalog 0.4 version, Hive we have 0.9, Uzi 3.2, Pig 0.9, Scoop 1.4, right? Now, if you want to look any of the functions which are available in Pig 0.9 version, you can go to the Apache website and look into that particular version, and it will give you the list of functions that are available. Okay. So the first thing is, from here you can actually look into what all versions are there on your box. Okay. Now look into the Hadoop and go into the configuration. Right. Once you get into there, you will find something called core site.xml, SDFS site.xml. Core site.xml is basically represent the configuration of the entire site. Okay. SDFS basically your Hadoop distributed file system related configuration will be specified in SDFS-site.xml, and then for the MapReduce, all the configuration will be get set in the MapReduce site.xml, which is the third file in this particular folder which you want to look into. Okay. So let me open one of it. So let's say we'll open the core site just to quickly show you the content, what it contains. So once it's good open, you will see various parameters which is already get configured, right? So FS default name, your temp directory, what is the trash interval, right? What is your checkpoints? All this information will be available over here. Any point of time, if you want to change it, you can actually go ahead and change it. All right. But make sure you understand the property very well before you go ahead and change anything onto your Hadoop cluster. Look into the SDFS site.xml. If I open it in Notepad, and one of the property I would like to show you, there you go. The selected one probably will take a couple of seconds to get reflected at your end. Yeah. So it's DFS.replication, right? We talk about the replication, how many, what is the value that you want to set it for the replication. Now, because it's a one node cluster, I have value 1. However, you can make it 2 or 3. That means your data will get now replicated 3 times or 4 times, whatever value that you're going to set it over here. Okay. And then if you want to change any modification with your MapReduce, you can come into the MapRed-site.xml, and you will find the information over here. Okay. Where your job tracker is listening, right? Where your job tracker, task scheduler, every information will be available over here. Okay, so let me just go ahead and close it. And if you go into any of these services, you will find the logs where you can actually find the log information. Okay, and similarly, if I mean that is in case if you want to troubleshoot something. If you go to the Hive, if you go to the logs, then you will get the Hive log here as well. Okay. This is just for the in case if you want to troubleshoot anything. Just look into what the logs are saying to understand the situation better. Let me just go and close it, and let me just open that Hadoop command line, right? So as I mentioned, you need to run the Hadoop commands. So I'll go ahead and write some commands just to show. So if I say sdfs fs -ls, right, which is a Hadoop distributed file system, I want to look into the file system, and I'm saying do the listing of it, right? If I did that, it basically gave me the information, okay? However, if I say lsr, which basically do a recursive, it basically shows everything which is there in the folders, under that folder, recursive search is going to do and give you the results. So as you can see, I've already uploaded some data for the demo purpose for today, okay? All right, and if you want to put any data onto your Hadoop cluster from your system, for example, I say SDFS, FS, then I can say copy from local. That means I want to move some files from my local system to my SDFS, right? So you need to provide the path then, okay? SDFS, FS -copy from local, and then it will take your data and put it onto the SDFS, okay? Now, let me go ahead and get into the PIG. So I'll say PIG, and it should open a grunt shell for me. Okay, this is available out of the box. So you just type PIG, and it'll open the grunt shell. Okay. Now I have an example which probably I'm going to share with you. Okay. So I have some data which I've already uploaded. All right, so I have a salary data which basically contains the gender, age, income, and zip. Okay, so I basically gonna load the data, right? And I'll quickly go ahead and paste it. Okay, so I have created an alias, which basically stores the data into the salary. So if I'm going to do the dump, which basically dumps the data into the screen, I say dump salaries. And now it basically gonna run a MapReduce for me and give all the results back on my screen itself. If you want to store that result rather than looking into the screen, you can actually go ahead and instead of dump, you can say store and provide the path where you want to store the data. Because you don't want to run your MapReduce task again and again, for a particular query. Now once this get done, what I'm going to do is I'll basically gonna filter out. I'm just showing you some basic example which you can run. For example, if you want to do the filtering of the data, you can just write a script. Oh yeah. The other option that you have with the PIG is you can actually go ahead and store all the commands in a one file, and you can execute the script file as well, right? So you can see I got the data. Now if I say I want to filter out some data, and then I'm going to say dump high salaries, and then again it's going to run the MapReduce job. In the meantime, it's running the MapReduce task for me. As you can look into the notepad, I have my salaries. That means it holds the data. In the next line, I'm saying filter the salaries by income, because I already defined the column as well, right? By income, where the income is greater than 35,000, right? And then dump that particular alias. So as you can see, I don't have to write any Java code. I can simply go ahead and run the scripts and get the things working. In the meantime, it's running. Let me say Hive as well. So as I mentioned, if you are comfortable with the T-SQL commands, you can actually go ahead and it should be show tables. So you can run SQL-like commands, right? There's no tables at this point of time, so that's why I'm not getting anything. But once you create a table, it will show you the list. So you can actually go ahead and write your select star commands as you do in the T-SQL world, probably from the table, right? It's as easy as that, right? So you don't have to learn Java for that initially, but if you want to do any customization or anything like that, then probably you need to have knowledge of Java. All right, and right. I mean, I can actually go ahead and run more. I have also have one more sample to showcase you, which basically read the log file and basically tells you how many errors, how many warnings are there, how many informations available on that particular log file. So the log file that you get from your IIS servers or web servers, right? You can actually go ahead and put it on to the Hadoop, and then you can either run pick commands or maybe hive commands to figure out how many errors are there, so that you can have a meeting with your application developers and tell them that these many errors that we are getting into this particular site, and then probably how to rectify, make it efficient, things like that. You can actually go ahead and do that, right? Otherwise, it will be a little time consuming. If you have a lot of data, first of all, you need to understand, how we're going to put it into the structure and then put it into the any RDBMS, right? But in the case of Hadoop, you can get that files, the log files, dump it onto the Hadoop cluster, and you can run your scripts and get the results quickly. Okay. Now with that, I think I'm a little overshoot with the time. I'll go ahead and take some questions. Okay. And in case if you want to connect with me, feel free to connect, and I'll be more than happy to have a conversation with you. Let me just go on to the questions over here.
Thanks for the insightful presentation, Sudhir. Let's quickly take up the questions now. As you have just mentioned, I request you to read out the questions and their answers so that all our users may listen to your insights. Are you able to see the questions coming into you?
Yeah, so one question that I see is, can we create multiple nodes on a single computer to simulate distributed system? You can actually go ahead and do it. I mean, through the VMs, you can create a VM environment, and if you want, you can have the SDP, the Hadoop, the Hortonworks distributed packages onto different VMs, and you can actually go ahead and play around with it. Okay. So the answer is possible if you want to have it on the through the VMs. Can you please explain MapReduce with example again? Shiva, I'm afraid because I'm running out of time. But I think we are gonna share these slide decks with all of you. So you can actually go ahead and have a look, and if you have any questions, feel free to let us know, and I'll be more than happy to clarify your doubts. Let's see. Now to make my secondary name node as a primary name node in case of a name node failure, I mean the procedure. The procedures, I can share the procedure with you, but quickly to answer, there's a manual steps which is required. I'll just quickly tell you that, once your name node gets failure, you take it out from the rack, put your secondary name node, and you have to change the configuration files and distribute these configuration files across the cluster to your compute nodes, right? So that they will know that the machine which was acting as a name node earlier is no more available. Now they have to talk to the machine which is come into the picture now, right? So there is some manual intervention is there. besides keep alive, what other data is communicated by data node to name node? So primarily is the it takes the heartbeat of it, and that's the that's the main purpose of any logs or any responses from the data nodes. That's where the communication will happen. Besides the keep alive. Can we create multiple node? Yes, so that I've answered. Can you? Okay. If there is no failure, will each copy of data still be processed? So if there is no failure, no. So whatever data that is there on that particular node, the task is basically to take and process it and give the results back. Okay. So each copy of data is not going to process unless it's required by that particular task on that particular node. Okay. Why should a data analyst or I think PGMR program manager maybe or the programmer worry about hardware config like node or JVM etc. Shouldn't that be abstracted? That's correct. I mean, as a data analyst or even a big data programmer or a developer, you don't have to be worried about hardware or the configurations like node or JVM. But as a developer or the programmer, I would say it will be good to have information with you so that if something goes wrong, you can actually go ahead and think about it, where the problems might happen. Okay, but I agree with you. You don't want to, because, and that's why the Hadoop is basically, has the option for data for the Hadoop administrators. We have Hadoop developers as well, right? So developers just write the programs for the analysis, and the administrators will take care of these hardwares and all. Okay. What about the Ab initio developer? Can an Ab initio developer work on Hadoop if she's not a Java developer? I'm not sure about your expertise. I mean, if you're comfortable with T-SQL or with the PEG, you can actually go ahead and start by understanding the Hadoop architecture, and then take one of the language which you are comfortable, like PEG or a Hive, and start your learning towards it. Okay, but behind the scenes, as you go further, you might need to have some understanding of Java, because behind the scenes it's used Java. So I wouldn't say that at the first step you require Java knowledge, but as you get into the deep information about your jobs or your logs, you probably need some information about the Java as well. And because it's a huge learning curve that's the community understand, they basically come up with these open source projects that you can easily start working with. What are the current tools or technologies that Hadoop will replace and make them obsolete? That's very tricky. I don't think so there's any tools or technology that Hadoop will replace, because if you look into the all other storage mechanisms or the solutions that provide you storing and querying the databases options, they have their own purpose, and so forth. The Hadoop has its own purpose in the market. Okay. I'm an Informatica developer. How much time it will take for me to learn Hadoop? That actually depends how much time that you're gonna put in, and at what level you want to be in. For example, if you just want to understand the Hadoop at level 100, 200, 300, that depends on the time. But if you spend good amount of time, I would say, fairly 3-4 months, if you dedicate your time well, you'll have a good understanding of your Hadoop. Replication of data consume more space. Can't we use any compression techniques to store the replicated ones to save space? There are a lot of programs that are available for the compression on the Hadoop world. That basically serves the same thing that you're mentioning in your question. So there are work is still going on the Hadoop community to achieve that, so that it will compress the data and store some space. What are the long-term prospects of becoming a Hadoop developer? There there are, as the industry is growing, but I cannot give you the, bullseye answer to it. But I feel, and I see there are some prospects for the becoming a Hadoop developer, because if you look into the industry's data growth, it's growing day by day, right? And they need to have some solution at some point of time. Though the rate of growth is a little slow at this point of time, but I feel it'll take up. Okay. Is there any web-based framework for Hadoop for writing web application? You can use Java is only there, and then from the Microsoft perspective, we have .NET framework which can help you to do that, but that too specific to the Microsoft solutions. But I'm not aware of any web-based framework for writing the web application. Do we have a Windows distribution of Hadoop, since I find only the Unix scripts in all the Hadoop distribution? We do have, Microsoft has the SD Insight service as solutions available in the market, which is a cloud-based. And at the same time, we have the SDI emulator, which is a one-box solution, which is available on the Windows platform, that you can bring it, install it on your box, and you can start writing. Or maybe you can look into the Hortonworks sites. They have their Hadoop distributed packages available for Windows. That also you can install it.
Due to the time constraints, Sudhir, yes, so I was just coming to it. I would request you to take the unanswered questions offline, which I will share with you through email. So we have a long list of questions coming to us. Thanks for all the interest that the attendees has shown. Please, I request you to take one last question and sum up the session for today.
Okay. Let me open that. How to avoid the name node failover? Any other options? At this point of time, there's no any other options. You have to do the manually. Automatic failover, I think so far is not available. You have to, there's no other option. You have to do manually. Okay. I think the rest of the questions I can take it over the email. Aradhana, over to you now.
Yes. So if you would like to sum up the session for today, you can do it now.
All right. So thank you very much, all of you, for attending the sessions, and get in touch with me. I have put in my contact information, and I'll also get a chance to learn with you, and I'll be more than happy to do that. So thank you very much again, and stay in touch, and keep learning. Thank you.
And I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Sudhir, for taking the time out and having us. I hope you have a great evening ahead.
Thank you. Thank you. Bye-bye.
Thank you. Bye-bye.